We've been talking about ionic compounds, and now we're going to talk about ionic compounds that have polyatomic ions in them. Really, the only difference here is that the polyatomic ion names are not necessarily intuitive, and they do involve a fair amount of just memorizing them. So names and formulas of polyatomic ions must be memorized. There's a whole bunch of them on the list of material to memorize, and I quizzed you on them with the memorization quiz. Polyatomic ions are groups of atoms that are covalently bonded together and collectively have extra electrons. When we're looking at ionic compounds that have polyatomic ions, one of the things that students sometimes try to do is they try to separate everything and try to talk about sodium and nitrogen and oxygen. Remember, it's two ions in Chem 1A. One cation, everything else is the anion. So when we look at this, sodium is the metal, that is the cation. If we cross that out, everything that's left is one ion, and it has a single name. So that one is called nitrite. And so this compound then is sodium nitrite, naming the cation, naming the anion. So this is very similar to the list of polyatomic ions I gave you to memorize. Some of these are more important than others. Hydroxide is really important. And then the eights, nitrate, phosphate, chlorate, sulfate, ammonium, carbonate, and acetate. So if you don't have time or the space in your brain to memorize all of them, at least memorize those green ones, okay? Those are the most important ones. Looking at these formulas, we see that most of them have oxygen in them. The ones with oxygen are called oxyanions. This guy down here is the one very strange one. It's a positive ion. Okay, the rest of these are all anions. So those oxyanions have oxygen and another element. And sometimes there's a series of oxyanions, that's not what I want to push. Like here, hypochlorite, chlorite, chlorate, and perchlorate. And we look at these formulas and they're similar. They all have one chlorine and a negative one charge, and the only thing that's different is the number of oxygen atoms. So the names for these follow a pattern. If there's just two ions in this series, the one that has more oxygen atoms ends in ate, and the one with fewer ends in ite. So this is nitrate, this is nitrite, sulfate, and sulfite. The difference is one oxygen, charge is the same, the other element is the same. Well, there can be more than two ions in a series, and so then we have to throw some prefixes in there to get enough different names. So there's chlorate, and then perchlorate. This prefix per means more. You think of hyper. A hyperactive person has too much energy, right? It's more, over the top. So per is more. This is the light version, and hypo is a prefix that means below. A hypodermic needle goes below your dermis, below your skin. So these are the oxyanions that chlorine makes. These are the oxyanions that bromine makes. Do you see a common pattern there? Perchlorate is ClO4 minus. Perbromate is BrO4 minus. So bromine, chlorine, and iodine are in the same family in the periodic table. They're like sisters, right? And they can wear each other's clothes. So they're going to follow exact same pattern. So what would be the formula for periodate? Not that one. Periodate. Just based on the pattern that we see here. IO4 minus. Okay? So you change the element that's with the oxygen, and you change this main part of the ion name for the part of the element name. So this is kind of a summary slide. And so this is what I recommend. Memorize the 8s. Those are mostly the ones I highlighted earlier, the ones that end in 8. So this one, chlorate. You should just flat out memorize that one. Chlorate is ClO3 minus because that's what they decided. There's nothing else to say about that. Perchlorate, like hyper, has more oxygen. It's got one more oxygen. Same charge, same number of chlorines. Chlorite is the light version. Bud Light has a third fewer calories than regular Budweiser, right? Chlorite has a third fewer oxygens than regular chlorate. Okay? And then hypochlorite, this is one less than chlorite. So these prefixes have meanings, and we can attach meaning to the ite one, right? And so this pattern should not be too hard to remember. You remember the pattern, and you memorize this one, and you can write the formulas and names for 12 oxyanions. All the chlorine ones, all the bromine ones, all the iodine ones. Okay? Let's practice naming. Name the compound SnClO3-2. Well, the slides haven't really introduced us to those parentheses. So ClO3 is a polyatomic ion. It's like a bundle pack, right? You go to Costco and you buy like 3 ketchups together, and they're like shrink wrapped, right? You can't just buy one. They won't let you, right? I suppose if you really wanted to, you could buy the 3-pack and like ditch 2 of them on your way out, but you know, who would want to do that? So this is like a bundle pack. And I think of the parentheses as being like shrink wrap around it, saying, okay, this is the package. The number outside the parentheses is how many of those we have, how many packages. So this is telling me that there are 2 of these ions, ClO3. Okay? So let's name the compound. First, we're going to look at the first element. What's the name of the element with the symbol Sn? Tin. Again, writing with the highlighter, not a good idea. Does tin need a Roman numeral? Yes, it does. It is not in groups 1A, 2A, 3A, zinc, and silver. So I don't know what that is yet, but I'm going to put the parentheses there, and I'll come back to that. And then we want to look at this, ClO3. ClO3. And in this example, we do need to know the charge. So you're probably not super confident about what the charge is. So don't just go look it up. Try to remember, make your best guess, and then check and see if you're correct. That way, over time, you will remember what they are. So if we look this up, it has a -1 charge. Well, what's the name of it? Chlorate. So, you know, you can kind of cut it down to only a few possibilities, right? Could be chlorite, hypochlorate, or hypochlorite or perchlorate. It's got to be one of those 4, right? This is definitely not carbonate. This doesn't have carbon in it. Okay, so that's chlorate. Now we have to figure out the charge on the tin ion. So let's just draw our little picture again. This is telling me there are 2 chlorate ions and there's 1 tin ion. So those 2 chlorate ions have a total of -2 charge. And so then the total positive charge has to be +2. And all that charge is going on the only metal atom there is. So that's going to be 2+. So we put the Roman numeral 2 in here, and we have tin 2 chlorate.
Now, could it be just from membrane 3A? See, I looked at that and automatically knew that tin would be 2 because the opposite of 2. Is that still okay to do? Or like if we get bigger and like different molecules, is that not safe necessarily?
So, like I can look at that and tell you it's tin 2. In this instance, this 2 is directly related to that charge, but only because the charge on chlorate is -1.
Right.
If it was -2, then it would be tin 4, right? So you do have to be a little bit careful. Any other questions? It's going to take some practice. Where's she? Write the formula for cobalt 2 phosphate. So we write the formula for the ions with their charges. So the symbol for cobalt is CO, lowercase o, because C, big O, is carbon monoxide, which is a very, very different thing. And what's the charge on the cobalt ion? 2. 2+, because that's what the Roman numeral is telling us. And then phosphate. PO4 -3. So at the very least, you should be able to guess it's phosphorus, oxygens, and some negative charge, right? Do your best guess, check your answer. Okay, so then we need to figure out how to put these together to get a neutral compound. So let's just stay with this pattern and let's see what we've got. Well, I've got +2 and -3. So that means I need more positive charges. The only thing I can do is add another one of those. That's a +2 charge. So now I have +4. So now I'm unbalanced the other way. So I have to add a negative ion. So now that's -6. And it's looking a little discouraging, right? Because we're just going back and forth. Just keep going. So now I'm short positive charges, so I'll put another cobalt in there. And now I've got +6 and -6. There's other ways to think about that. But if those other ways make sense to you, you probably don't need me to explain them to you. So then our formula here is cobalt, not 2, cobalt 3, and then this phosphate as a polyatomic ion, and there's more than one of them. There's going to be 2 of them, so I need to put shrink wrap around it and put it on the outside. Because if we wrote PO42, that would be 42 oxygens, right? That's ridiculous. That's not what we mean. So we need the parentheses to be clear about that we're talking about a multiple of this polyatomic ion. If you have a monatomic ion, like maybe you have this compound, iron 3 chloride, where there's 3 chloride ions, we don't need the parentheses because there's nothing to get confused about. And so we don't want to write extra things. Any questions? So some ionic compounds have water molecules within their crystal structure, and these are called hydrates because they have water in them. So here we have pictures of, this is cobalt 2 chloride, hexahydrate. This compound has 6 water molecules for every formula unit when it crystallizes, and it has this pretty pink-red color. And anhydrous, meaning without the water, cobalt-2 chloride, is purple in color. These are 2 different compounds. This is not just taking this and sprinkling some water on it. The water is incorporated into the crystal structure, and it's in a specific ratio. So we're not going to see these a lot, but we do need to know how to name them and write their formulas. So the formula for Epsom salts, which you may have used to soak your feet or something, that's magnesium sulfate, and we have this dot and the number 7, H2O. So the 7 here is telling me there's 7 water molecules in this hydrate. The dot is not a multiplication dot. It just means these guys go together. I don't know why they decided to write it that way, but they did. So if we write the name of this, we're going to name the ionic compound in the beginning, so magnesium sulfate, and then hepta for 7, hydrate. COCl2.6H2O, that's cobalt-2 chloride hexahydrate. So we're using these prefixes. Most of these make sense. Mono is 1, di is 2, tri is 3. Tetra, that's one we don't use much in everyday life, but Tetris, the game, all those shapes had 4 squares. Tetra means 4. And then you think about a pentagon, a hexagon, an octagon, a decagon, the number of sides, right? Those make sense. Hepta you don't hear about much. That's 7. Nona is like Nina, right? Or Nina. We've got nano and nona and 9, and they're all 9s, okay? And then hemi means half. So let's practice naming these hydrates. So we're going to name the ionic part first. So what's the name of this element? Calcium. And does that metal need a Roman numeral? No, because it's in group 2A. And then what's the name of everything that's left? Sulfate. Sulfate. And then we're going to use a prefix for this number, which would be hemi. And then to indicate the water, we call it hydrate. So calcium sulfate hemihydrate. A hemisphere is half of a sphere, right? How about this one?
Barium, is it sulfite? Oh, it should be 2 because barium is in group 1 and 2, right?
Yeah, barium does not need a Roman numeral, right? Because it's in group 2A. And then, so, let's cover that up.
That's sulfite or just chlorine?
No, you're having a brain fart. That's chlorine, right? So it can't be sulfite,
Right.
because that would be sulfur, right? But yeah, we were just talking about chlorate, but is there any oxygen? No. And sometimes this 2 messes with you. Well, that's telling me there are 2 of those ions.
Dichloride.
So the numbers of each come from looking at charges. That's not part of the name. So chloride, right? So this is chloride. The ions that are in that compound, let's bring this back, are barium 2+ and Cl-. And there are 2 of the chlorides because we need 2 of these to balance that charge, right? And then the prefix for 6 is hexa. Hexa and 6 both have an X in them. And then hydrate. So let's write the formula. Copper 2 sulfate pentahydrate. What's the symbol for copper? Cu. And the charges.
It's telling us that it's 2.
Pardon me?
I was saying it's telling us that it's 2. because
Yes.
of Roman numerals.
Yep, the Roman numerals are flat out telling us the charge, right? And then sulfate. Give it a shot. SO4. 3 minus is a good guess, but not correct. It's 2 minus. You can't look at the charges that sulfur and oxygen would take as ions, because this is not composed of sulfur and oxygen ions. It is sulfur and oxygen atoms that are covalently bonded together, and as a group they have 2 extra electrons. And so at this point there's no nice way of seeing why it would be -2. Well, how do we write the formula for copper sulfate then? We've got +2 and -2, right? We don't need to mess around. It's just going to be CuSO4. And then the prefix penta means 5, so we're going to put a dot there. 5, and for hydrate, we're going to write H2O. These hydrates are going to come up every once in a while. They are not a big deal. Being able to name or write the formula for the ionic part of this is a big deal.